Saudi Arabia invested a massive sum, $2 billion, in the purchase of Chinese laser air defense systems. Now, it turns out the money was wasted. What was sold as a revolution in drone defense turned out to be far from what was promised. This story is a serious reputational blow to China, raising the question of whether its weapons are truly fit for real combat conditions or are just a glossy showcase with little substance. Let's start with what the Saudis actually bought. The system, called Sky Shield, combines radar, optics, electronic warfare, and laser modules. The concept is simple: burn an enemy drone with directed energy without spending expensive interceptors. The Chinese state-owned manufacturer CCTS advertised the system as proven and reliable, claiming that in testing, it achieved a 100% interception rate against an attack of 20 drones. According to statements, similar systems have already been sold to several countries. The demand for such technology is high for a clear reason: drones have become a cheap and effective threat, especially for countries whose economies rely on vulnerable oil infrastructure. A single mass drone raid can disable extraction or refining facilities and inflict massive economic damage. For states in the region, protection against UAVs is a top priority, and they are seeking solutions that are cheaper and faster to operate than traditional missile systems. But testing and real-world deployment are two very different things. According to open sources and former military experts, Sky Shield experienced major failures in the field. Instead of instantly burning drones out of the sky, the laser often required between 15 and 30 minutes of continuous exposure to disable a single drone. In combat, where attacks come in waves and drones move at high speed, such performance is unacceptable. The reasons are technically simple, but critical. A laser requires enormous power and effective cooling. In the desert, both conditions are problematic. Heat reduces cooling efficiency, while dust and sand scatter the beam and disrupt tracking systems. In addition, preparing and deploying the system turned out to be cumbersome. In rapid response situations, such systems must be able to power up and operate immediately, not after lengthy setup procedures. Why did Beijing decide to sell the system despite its flaws? The answer lies in a mix of political and economic incentives. State corporations, under pressure to report progress and achieve ambitious goals, often present overly optimistic test results. The push to expand arms exports and strengthen geopolitical influence encourages faster commercial moves than might be wise. For China, this is a way to increase its share of the global arms market and project influence through weapons sales, but at the cost of potential reputational damage if the technology fails buyers. Another factor is the lack of extensive real combat experience. Many Chinese systems have been developed and modernized in test ranges and labs, but have not been battle-tested. This stands in sharp contrast with systems from countries whose weapons have been refined through multiple conflicts and upgraded based on real operational feedback. When billions and critical infrastructure security are at stake, buyers expect proven solutions, not systems tested under ideal conditions. It is also important to consider the commercial logic. China sells cheaper alternatives to Western systems and often wins on price. But economies of scale and buyer trust are not the same thing. One major failure with a large client can discourage other countries and derail expansion plans. What does this mean for Saudi Arabia? First, Riyadh is forced to return to proven solutions, strengthening electronic jamming capabilities, reassessing the mix of defense systems, and possibly increasing the share of physical interceptions with missile systems despite their cost. Second, there is growing interest in deterrence measures, not only defense, but also the ability to deliver a symmetrical or asymmetrical response to reduce the motivation for attacks. And third, there is now a stronger incentive to develop domestic defense capabilities. Investing in national industry provides control over critical technologies and reduces dependence on imports. For China's defense industry, this is a warning. Quick sales without objective combat verification carry serious reputational risks. Military technology is not just about price and specifications. It is about trust, backed by real-world experience. If China wants to expand its exports and compete among the top suppliers, it will have to combine marketing with honest capability assessments and actual field testing. The bottom line is simple. $2 billion is not just a lost sum. It is a lesson for both buyer and seller. In defense, trust is the most valuable asset, And if the technology cannot withstand real conditions, no polished demonstration or impressive figures will protect either critical infrastructure or the manufacturer's reputation. Beyond the direct technical and commercial consequences, this story also has a political dimension. A public failure involving such a major purchase gives critics inside the buying countries and their external partners a powerful platform. In the Saudi elite, questions will inevitably arise. Who was responsible for the verification? Why there were no stricter field tests? And who will be held accountable for the obvious gap between promises and reality? This will lead to tougher procurement procedures, the introduction of additional audit mechanisms, and possibly a shift toward suppliers with established reputations, meaning the same American and European defense contractors with long track records and reliable service support. At the regional security level, this will reinforce the paranoid logic of better safe than sorry. Countries vulnerable to infrastructure attacks will start actively seeking backup solutions, hybrid countermeasure networks, the integration of signal jammers, sensor grids, and traditional missile interceptors. Interest in layered defense will grow. Lasers may remain on the list as complementary tools, but the backbone will consist of systems proven through years of real-world testing. This means demand for cheap but unproven solutions may decline, and the market niche China hoped to dominate will become more closed and demanding. Economically, for Saudi Arabia, the failure is more than just writing off $2 billion. It brings additional transaction costs, expenses for dismantling, disposal or modification of ineffective modules, repeat purchases, maintenance, and potentially compensation to contractors and partners. Lost time is another critical factor. In a heightened threat environment, even a few months of ineffective protection mean real vulnerability. Given the scale of the oil industry, a single successful strike could offset years of any manufacturer's development costs, entirely through the economic losses inflicted on the targeted country. There is also a diplomatic dimension. Major arms deals are not just commercial transactions but instruments of influence. When a purchase turns into a public failure, it undermines not only the manufacturer, but also the entire partnership policy. Other countries will be more cautious about signing strategic agreements, fearing that dependence on the supplier could become a liability. As a result, China risks losing not only market share, but also long-term political dividends that were meant to grow through defense interdependence. What can Riyadh do right now? A practical roadmap would be to revise and tighten acceptance standards for military equipment, conduct joint field tests in local climatic conditions before signing final delivery documents, demand guarantees and rapid repair or replacement channels from the supplier, invest in localizing critical components and in domestic R&D, and at the strategic level, build a layered defense system where lasers play a supporting rather than primary role. Finally, for the global arms market, this episode serves as a reminder of the real rules of the game. Paying a high price does not guarantee value. Reputation, after-sales support, real field testing, and transparent reporting matter far more than polished promises. China can learn from this and adjust its approach. Buyers can adapt their procedures and demand stricter proof of effectiveness. And manufacturers worldwide can recognize that refining technology in a lab is only half the work. Durability and reliability in the field are what truly determine the value of a system. In the end, the $2 billion story is not just about money. It is about how, in an era of rapid technological sales, infrastructure vulnerability and trust between states have become strategic currencies. And once trust is lost, regaining it costs far more than any original investment.